Okay, so the second notes for 3B.5. We're going to go ahead and bring back out that reference chart and talk about our next one, ASA. ASA is going to stand for angle, side, angle. Okay, we're going to see a lot of similarities with how this one works as with the side angle side. But in this case, we are going to make sure that we, at the bottom, we're going to go ahead and write in, we have two angles and the included side. So with the other one, we had two sides and the included angle. This time it's the other way around. Okay? So we have here, we'll go ahead and start with angle. So it's like us saying, all right, this angle right here is going to be congruent to this angle. Our side, we'll say that this side is congruent to this side. And then because it needs to be included, it needs to be between the two, the S is between the two A's, so the side has to be between the two angles. So then this would be our second congruent set of angles. Okay? So again, just like this, we have the A in between the two S's. Here we have the S between the two A's. This is one of the easier ones to see. Okay, we're going to put that to the side and bring out our angle, side angle foldable. We are looking at here again if two angles and the included side of one triangle are congruent to two angles and the included side of another, then they are congruent. So again, we'll take a look like what we did on the reference page. Here we're going to have angle A is going to correspond and be congruent to angle D. So here it says angle. Angle A is congruent to angle D. And we are going to have side, so our segment AB is congruent to segment DE. Followed by our last set of angles here. Angle B will be congruent to angle E. So we have two angles and the included side, the one that actually joins the two angles together. So you go in a straight line, angle, side, angle. All right? If these three hold true, then angle ABC will be congruent to triangle ABC will be congruent to triangle DEF. Okay? So let's open it up, and mine was printed correctly. You'll have to rotate yours and take a look at our proofs. So the first set of proofs here, we'll start off with segment SQ bisects angle RQT and angle RST. So let's start one thing. First of all, this is a given. And we'll go one by one. First, SQ right here is going to bisect angle RQT. And as we know, bisect means to cut in half. So that whole angle will be cut into two congruent angles. It is also going to bisect angle RST. So these will be cut into two congruent angles, but again, we have to make sure that we're putting the two arcs there. Okay? We move to statement number 2. We're saying that angle, and watch the pen as it goes, angle RQS, this angle right here, is congruent to angle TQS. We already have that marked, and why did we mark that? This word bisect. Okay, and what are we bisecting? An angle. So this will be your definition of an angle bisector. Statement number 3, following the pen, is saying that angle RSQ, this angle right here, is congruent to angle TSQ, this one. Again, we were able to go ahead and jot that down because the same thing here. SQ bisected the bigger angle. So same thing as right here, we have the definition of angle bisector. What told us that those were going to be congruent? The fact that this bisected. Okay? Statement number 4 says that segment QS is congruent to segment QS. We should be getting used to seeing this. Same thing on both sides. We have our reflexive property. And then we go up here and we mark that that's congruent, your shared side. Again, that's where we talked about shared side. We came over here and said, why? What are reasons? Reflexive property, shared side. The two triangles share that side. They're connected. You have a triangle here, and you have a triangle here. Lastly, now we're saying the two triangles are congruent. So it has to be one of these congruent statements with our letters. So if we go back over here, like we've talked about labeling S's and A's, we have a side. Sorry, it's an angle. Let me find my white out. Hidden somewhere. Side's in the middle. We have an angle, followed by a side, followed by an angle. What's great about this is you'll see it written in an exact straight line, ASA, because there are two different congruencies, triangle congruency theorems that are going to be two A's. So this one, straight line. Okay? So we know this is ASA congruence. Right? The next one, we are looking at segment WO is parallel to segment SK. So we come over here, and over here segment WO is going to be parallel to segment SK right here. Knowing that we have parallel lines, we may wind up with something here. Okay? Keep that in mind. We are going to start seeing some blanks on the statement sides now, okay, so that you guys can better understand the reason sides. So statement number 1 here, we need to write in the first given, okay. This is going to be segment WO, it's parallel to segment SK. And we can look down here and we see that this other given is written over here, so we don't have to write both. The first statement is always going to be your first given. Okay, just like number 1, your first reason is always the word given, your first statement will always be the first given. Next, angle W, okay, so right here, angle W is congruent to angle K over here. So we're saying that these two are congruent. It's not a given, but there is something else that tells us this, and we looked at this with the last notes. If these two lines are parallel, we can extend them out, and we can take a look at, we have two different lines that are transversals. Well, the one we want to look at as a transversal is the line that these angles touch, that angle W and angle K touch. So here, this will wind up being our transversal. And then if we ignore, this section right here and this section right here, we have our two parallel lines cut by a transversal. And look at W, angle W here, and angle K over here. And we see that they are on alternate sides, and they are interior to the parallel lines. So, because we're saying that the angles are congruent, it's not the converse. It's just going to be the regular alternate interior angles theorem. The next thing we have is another alternate interior angles theorem. So we have to take a look at, there is another set of alternate interior angles other than W and K. So if we switch this up and we start looking at, okay, let's look at the other transversal. So now we're going to cover these up, and we're going to look at segment QS. And we're going to take this and extend it, and now we're going to look at that as our transversal, so that we can determine what angles do we need to say are congruent over here. So if this is our new transversal, we have this angle right here, and this angle right here are alternate interior angles. Cover up the other segment, we have our parallel lines, and then that orange transversal, look at where I marked, okay? Angle O and angle S, right here and up here. Those are alternate interior angles. So those are the two angles that we're going to state are congruent over here. So we will say angle O is congruent to angle S. So we've gone a little backwards here. We've looked at the reason that they're saying this blank over here is because they're alternate interior angles. So we need to go find another set of alternate interior angles and state that they're congruent over here. Right? We move to statement number 4. Segment WO is congruent to segment SK. This is going to be a given. Then we want to make sure that we go up and we mark that. Okay? So WO is congruent. Segment WO is congruent to segment SK. A lot of markings going on here, okay? So we'll focus here now on the fact that we now have two triangles congruent. How do we know? Look at your congruent markings. We have an angle, then a side, then an angle. Again, it'll be in a straight line. It may not be horizontal like this, but we see it in a straight line, ASA. And that's how we know that's the order. The last statement then, since we have now proven, okay, we've already done two foldables like this, we have proven that two triangles are congruent, therefore all corresponding parts are congruent. So OR, right here, will be congruent to RS right here because these are your two triangles here and here. So OR, these two letters, and RS, those are going to be congruent. How do we know? Because according to CPCTC, once we have proven two triangles are congruent, all corresponding parts are congruent. Okay? The third one, we will take a look at the first. It's always going to be a given. Angle BAC, so B to A to C, is going to be congruent to angle DEC. These are congruent. It's given. Next, C is the midpoint of segment AE. So this right here is going to be a midpoint. How do we know? It's another given up here. So because it's the midpoint of AE, midpoint again, we're splitting that huge segment in half, two congruent segments. So then statement number 3 says that segment AC is congruent to segment EC. So segment AC is congruent to segment EC. How do we know? What told us that? That word midpoint. So we have the definition of midpoint. Moving to the next statement, we have angle BCA. Okay, so this angle right here is going to be congruent to angle DCE. And again, we look at our reasons that angles. Look at that. We have our vertical angles again. You see that? Vertical angles. So this will be your vertical angles theorem. Last thing is to prove the triangles are congruent. So we need to figure out what order did the letters go in. Well, here I have an angle, side, angle. The side is between the two angles, so the S has to be between the two A's. So ASA theorem. All right? That concludes our notes for 3B.5.